All right, so here we have section 2.3, kind of continuing on the stuff we did in 2.1, 2.2, just adding to it a little bit. All right, so the hypothesis of a conditional statement can be represented by the symbol P. Lowercase p is a symbol that represents hypothesis. Conclusions represented by a lowercase q. And so by giving those symbols, they allow us to do a little bit of shorthand work here. All right, the symbol, just an arrow going to the right, is read as implies. So a conditional statement can be written symbolically as follows: if P, then Q, or P implies Q. Right? So this shorthand form here is the same thing as saying if P, then Q, and it's representative of a conditional statement because we're starting with P, which is the hypothesis, ending with Q, which is the conclusion. The converse can be written symbolically as follows. So if Q, then P. So remember, converse switches the order, Q and P. So the conclusion goes to the hypothesis, and the hypothesis goes to the conclusion. So we've just switched P and Q here, right? Now, a biconditional statement is written if P, then Q, and if Q, then P. Right? It's kind of what it replies or represents because it's the conditional and converse together. But the shorthand form, we give P and Q with a double-sided arrow there because that means that the statement can go in both directions. Right? It's because it's a conditional and a converse together in one. All right, so most commonly you would read that P if and only if Q. So represent this double-sided arrow as if and only if, because that's what's required for it to be a biconditional, is that statement. All right, so let P be the value of x is -4. Q is the square of x is 16. So we're going to write P implies Q, or if P, then Q. So in that order, we're talking about a conditional statement. And so starting with P, we're going to say if the value of x is -4, then we're going to bring in the Q, then the square of x is 16. So then next up from there, write if Q, then P. Q implies P, which is the converse, and Q comes first. And so if the square of x is 16, then the value of x is -4. And so then we want to decide whether the biconditional statement P if and only if Q is true. And remember, in order for a biconditional statement to be a true statement, both the conditional and the converse have to be true statements, since the biconditional is representative of both statements put together in one. And so if I look at the first one, the conditional, if the value of x is -4, the square of x is 16. And if I take -4 and I square it, that is going to equal 16. So that does work. So that's a true statement. If I write the converse here, if the square of x is 16, then the value of x is -4. So if I say x squared equals 16. If I take the square root of that, is -4 the only answer I could get there? Right. Remember, when you insert a square root to solve, you also have to put a plus or minus in there. So that would give us x is plus or minus 4. So you've got +4 as a possibility or -4 as a possibility, where if you square it, you get 16. So -4 is not the only possibility, which means the converse is false. Which means that the biconditional would be false because the conditional and converse were not both true. All right, the symbol for negation is that little squiggly line there, right? And so if I see this little squiggle in here, that's negation. Remember, negation is putting in the word not or turning it into a negative statement. So the inverse and contrapositive of if P then Q are as follows. Inverse is the negation of P implies the negation of Q, or if not P, then not Q. Contrapositive is just the opposite order, but they still have the negations in there. If not Q, then not P. So let P be today is Monday and Q be there is school. So we want to write the contrapositive of if P then Q. Contrapositive being if not Q, then not P. So we're going to take the Q. So if there is, and we got to put a negation in there, no school, negation right there, then today is, and we got to put another negation in there, not Monday. So there's our negation there, or that's representative of the little squiggly line, right? All right, so then the inverse of if P then Q, inverse would be if not P, then not Q. So basically it's taking what we just wrote for the contrapositive and we're flipping it around. So if today is not Monday, then there is no school. Right. Once again, we've got our negations in there, starting with P, ending with Q. All right, so then deductive reasoning and inductive reasoning. We've already talked about inductive reasoning in chapter 1, so deductive reasoning is the new thing here. So deductive reasoning uses facts, definitions, and accepted properties in logical order to write a logical statement. So deductive reasoning is taking stuff that we know that is factual, real data, and creating a logical argument from it. Whereas inductive reasoning, if you remember, uses previous examples and patterns to form a conjecture, right? We had to recognize a pattern, and then based on that pattern, we made a conjecture. So deductive reasoning is a little more factual than inductive reasoning. So we wanted to determine whether these two reasonings are inductive or deductive. So first one says, Josh knows that brand X computers cost less than brand Y computers. All other brands that Josh knows of cost less than brand X. Josh reasons that brand Y costs more than any other brand. So the key here to determine whether it's inductive or deductive, we're looking to see, is he using real facts, stuff that we know that is guaranteed true, or are we using his recognition of a pattern? So it says all other brands that Josh knows of cost less than brand X. So he's taking the fact that he knows X is less than Y, and everything else that he knows of is less than X. So he's going to reason that Y is the most expensive brand out there. But because it's just what he knows of, and he's making a generalization to say it's more expensive than any other brand, there could be brands that he doesn't know of. So this is him developing his own pattern and recognizing his own pattern. So this one is actually inductive. Right. And B, Josh knows that brand X computers cost less than brand Y computers. He also knows that brand Y computers cost less than brand Z. Right. He can see the price of X, knows it's less than Y. He sees the price of Y, knows that it's less than the price of Z. So he reasons that X costs less than Z. So Y is that one in the middle, right? So X is less than Y, but Y is less than Z. So X would also have to be less than Z. So this is all based on facts, things that he knows for sure. And so this one would be deductive reasoning. All right, when we look at deductive reasoning, there are two laws that we can use for deductive reasoning. We have the law of detachment and the law of syllogism. All right, the first one, the law of detachment, and the definition of it is that if P then Q is a true conditional statement, then P is true, and P is true, then Q is true. So if we have a conditional statement that is true and applies to a situation, if the P portion happens, the hypothesis portion happens, then that means that the Q portion has to happen also. So, state whether the argument is valid. Michael knows that if he does not do his chores in the morning, he will not be allowed to play video games later the same day. So, looking for hypothesis and conclusion. If he does not do his chores in the morning, then he will not be allowed to play video games later. So, if he does not do his chores in the morning, that's the P part, right? And then not allowed to play video games is the Q part. So it says Michael does not play video games on Friday afternoon, so Michael did not do his chores on Friday morning. So this is saying that since he didn't do his chores in the afternoon, he must not have done, or since he didn't play video games in the afternoon, he must not have done his chores in the morning. Which law of detachment says if the P portion is true, the Q portion has to be true. And playing video games is not the P portion of the statement, it's actually the Q, right? It's the result. It's what happens if this doesn't happen. So just because he doesn't play video games, it never told us that he didn't do his chores. So we can't go in reverse and say he didn't play video games, so he didn't do his chores. It was Friday afternoon. He may have had a football game, or may have been going out on a date, or may have just went home and taken a nap. Who knows? Could have been any reason why he didn't play video games other than the fact that he didn't do chores. So we cannot reason that he did not do his chores there. So no would be the answer there. It's not a valid reasoning. Now B, if two angles are vertical, then they are congruent. All right, so this is an if-then statement. So we have the P portion here. The then portion to the Q. Right. If P is true, then Q has to be true. Angle ABC and angle DBE are vertical. So angle ABC and angle DBE are congruent. So it tells us that angle ABC and angle DBE are vertical, which reply is based on the P portion, the hypothesis portion. if two angles are vertical. These two angles are vertical. So if you have vertical angles, then this result, this Q, has to happen. So we know that this has to be true. So angle ABC and angle DBE are congruent. So this would be, yes, that is a valid reasoning. All right, so then the next one here, the law of syllogism. If P then Q and Q then R are true conditional statements, then P then R is a true statement.
Kennedy Jacob, can you please come to the high school office? Kennedy Jacob.
Okay. So, since the law of syllogism basically is comparing two different statements, in one statement the conclusion is the same as the hypothesis in the other statement. So if those two are compared, if this happens, then the conclusion of the second statement has to be able to happen also. So write some conditional statements that can be made from the following true statements using the law of syllogism. If a fish swims at 68 miles per hour, then it swims 110 kilometers per hour. If a fish can swim 110 kilometers per hour, then it is a sailfish. So, in this example, first statement is P then Q. So the second one would be Q then R, because they both say swims at 110 kilometers per hour. Right? So we can make a new statement based on that, which says if P happens, then R happens. Right? So basically what we're doing is cutting out the part that's the same from those two, and we're making a new statement that says if a fish swims 68 miles per hour, then it is a sailfish. All right, so then if we look at the next two statements, if a fish is the largest species of fish, then it is a great white shark. If a fish weighs over 2,000 pounds, then it is the largest species of fish. So when we look at these two statements, right, the beginning of this one is the same as the end of this one, or the hypothesis of this one is the same as the conclusion of this one. So we're going to look at this as if P then Q, and that's Q then R. Right, so we cut out the part that's the same. Largest species of fish, largest species of fish. If a fish weighs over 2,000 pounds, then it is a great white shark. And I'm not sure about the validity of this statement. If it's over 2,000 pounds, it has to be a great white shark. I'm not sure if great white shark is truly the largest species of fish. Don't get caught up on that. We're just trying to put these two statements together and cutting out what's the same, putting together the other two parts together. And then we can make, we got statement 5. If a fish is the fastest species of fish, then it can reach speeds of 68 miles per hour. So we can take fish swims 68 miles per hour, then it is a sailfish. So the 68 miles per hour, if we cut those two out, then we can get a third statement that's going to say if a fish is the fastest species of fish, then it is a sailfish. All right. So then lastly here, Casey goes to a music store. Given the following true statements, can you conclude that Casey buys a CD? So it tells us that these statements are true, so we have to follow it just like everything in this is true. So if Casey goes to a music store, she shops for a CD. If Casey shops for a CD, then Casey will buy a CD. So we want to know if she goes to a movie, she's going to a music store. Will she buy a CD? So if she goes to a music store, she shops for a CD. And if she shops for a CD, then she'll buy a CD. So the new statement we can make from that is if Casey goes to a music store, then Casey will buy a CD. They told us that she went to a music store, so what can we conclude? Casey buys a CD. So that concludes section 2.3 with a few interruptions.